So, our last speaker of the day, Professor Bellare.
Thank you very much, Peter. Thank you. So, respected friends, it's my pleasure to try and present to you some hard data. And this hard data is in support of our findings that there is a very simple material basis to homeopathic medicines, and that material basis happens to be nanoparticles of the starting material. Right? This is a finding that we've worked on for some years now, and in view of the short time available, I might skip some of the detailed slide which I use on skeptics, but I find none here, so I can touch on the highlights alone. So our interest in nano came about because of their biological importance, and we've been working on nanoparticles in allopathic medicines for drug delivery systems, which got us into Ayurvedic system of medicines and eventually into homeopathic system of medicines. And what we've done in homeopathy is to try and answer three basic questions. What is there in the medicine? How did it get there? And how does it act? So these are the three answers to these three questions, which I'll tell you very quickly. And what we've done is to do a physicochemical characterization and to look at the biological action in cell lines. And here, of course, we are looking at fundamental science. And to touch upon the physicochemical aspect, the process of titration adds lactose and produces the nanoparticles which eventually will stay behind in the system of medicine. Very analogous to what modern material scientists do by the process of comminution. The second important part of the process is the succussion, which provides not only energy to the system, but it provides a means of separating large and small particles by the process of froth flotation, which I will illustrate a little later. There are, of course, umpteen theories. Right? When you talk about extreme dilutions, does anything remain? And the answer is yes, it does. Theory number 10, which is ours, which says the nanoparticles of the starting material do remain, and here is the evidence for it. So our efforts are to understand this so-called super Avogadro dilution and to relate it to the process of manufacture. And what we've done, here is a one-slide summary, that we've shown by electron microscopy that these nanoparticles remain. These are nanoparticles of the starting material, and we've shown that they are generated and they stay on despite the high dilutions used. So here are some of the papers which we published, which I'll just skip through, including one in a mainstream ACS journal, Langmuir, and several others. So let me skip through those quickly. The medicines which we've looked at are, we began with metallic systems because they're easy to look at in electron microscopy. We've also moved on to inorganic salt-based medicines. We have not been able to do herbal medicines nor no-sods. So our work is restricted to metals and metal salts. And we use electron microscopy, which is expensive, fancy camera to produce images of tiny things. And these are the tiny things which we look at. So you can see these nanoparticles here. So this is like a passport photograph. These are the crystallites which light up. It's like an X-ray image or a digital radiograph, which shows you the insides of the system. And this is the thumbprint or the fingerprint of the system, which is the electron diffraction pattern, which can uniquely tell you what is the element that is present in that particular sample. So you can get the bright field picture, so to speak, the dark field picture, which gives you the internal structure, and you can get the chemical composition by merely looking at this distribution of dots, which amounts to a fingerprint of the system. And the fingerprint can be looked up in tables like this, much like FBI's database to catch the criminal, and we can figure out who the criminal is. So with this information, here is zinc met 30C, well below Avogadro's, but right here are the particles, here are the crystallites seen, and here is the fingerprint indexes perfectly to zinc metal as per the standard databases, and so on. So there's plenty of evidence here which I'll skip through. We can measure the particle size distribution. Most of the particles are in the 5 to 10 nanometer range, the crystallite size. So we've shown that the particles of the starting material remain. This, of course, was a zinc medicine, began with zinc, but we've shown it for several other metallic systems. They contain nanocrystallites. Can we measure them quantitatively? And the answer is yes, with modern tools such as ICP-AES and ICP-MS, which are tools which are analytical tools, we can see that there is a very definite concentration of picograms per ml, few hundred to few thousand picograms, drops with potency until about 6C, and thereafter it levels out. Each of these is a measurement from different batches, different suppliers, so there is no error in a single, the error of a single measurement is within the symbol, but you can see there is error between manufacturers, between batches of the same manufacturer. How does this happen? We have a theory here which essentially says that the lactose-coated particles froth float when you subject it to succussion. Succussion causes hydrodynamic cavitation. You bang a bottle of liquid and it's going to froth around. The froth carries with it these nanoparticles to the surface, and then in the process of successive dilution, which happens subsequently, whether by a Hahnemannian process or a Korsakovian process, these particles slip into from one dilution to the next, much like the cream on my milk slips into my into my cup of tea, whether I like it or not. This is very analogous to that. So what happens eventually is that these nanoparticles get carried from dilution to dilution. It's only the nanoparticles which froth float to the surface, and in time these bubbles go away within a few seconds or minutes. And how do we know that? We know that because we have done high-speed video photography which shows these particles being generated. This is a sequence of images which is at the bottom of the container. If you look at the top of the container, these nanobubbles remain. We can't see the nanoparticles at this resolution, but they do rise, and you can see that this froth remains for some time. This process of froth flotation not new. Metallurgical engineers and miners have been using it for centuries, perhaps, to beneficiate their ores. The only thing here is that it beneficiates the nanoparticles into the final system. Yeah. So this lends credence to this hypothesis that froth flotation is responsible, or one of the key steps. Yeah. We then extended this work into inorganic medicines, where we showed that despite water solubility of even common salt, it turns out that in alcohol-water mixtures, common salt is insoluble. And that's what causes even water-soluble salts to follow the same nanoparticle theory of formation that I just now described to you for metals. And with these inorganic-based medicines, we find similar results. Here is the passport photo, here is the X-ray, and here is the fingerprint. And I have tons of data like this, which I won't dwell upon. Tells you that in this medicine there's only sodium chloride present, yeah. And so on, yeah, with many other medicines of this sort. Yeah. We also see that there is a silica coating that forms, and we have a hypothesis of how the silica actually is deposited chemically. Some of the sodium silicate leaches from the glass walls. It contacts the ethanol solution, where it forms some polysiloxane chains, which then deposits on the particles, on the nanoparticles of the original substance present. Here is a cartoon which I will skip for brevity, and shows, and so all this indicates that there is this silica coat which forms on the outside of these particles. Yeah. Last point, last 2-3 minutes is so what? Well, so what is that it does it at these small concentrations, is there any biologic effect? And the answer is yes, there is. How do we know that? We know that because we've studied that in cell lines. Yeah. And and this is published also. What it is based on, this concept is based on Hormesis, which said that for every substance, small doses stimulate, moderate doses inhibit, and large doses kill, which of course has an analogy with the basic principle of homeopathy as well. So here we see a typical dose response curve, which shows that at large doses things go bad, but there is a dose regime, and this dose regime happens to be in a rather low concentration regime. Sometimes people call it a biphasic response, in which there may be a similar curve at much higher concentration, which most conventional medicines, allopathic medicines, do use. But here we find an action at these low doses which are present in these ultra-high dilutions as well. Yeah. This is data now from homeopathic medicines. I should make it very clear that the homeopathic medicines we've studied so far are commercial ones. We've not made any in our lab, bought straight from the market. Anyway, so it shows here that what's on the y-axis is the so-called MTT activity. It shows the activity of the mitochondrial activity in the cells, and the 100% line is where it should be, and the control is close to that. Once we start adding these homeopathic medicines and change their dose, we find that there is a dose response curve in which the MTT activity increases significantly. This depends, of course, on the type of medicine, and it depends on the cell line we use. And the data has now been published, and we are generating. generating even more data. So to close then, what I hope I've shown you is that in homeopathic medicines, the nanoparticles of the starting substance remain despite super-Avogadro dilution. These nanoparticles have a core shell morphology. There is salt or metal at the core and a mesoporous silica layer on the outside. It is likely that these nano or similar nanoparticles exist with all homeopathic medicines. Titration and succussion are important parts of the process. Hormesis seems to be the biological basis of action on the cell lines that we studied. And above all, it turns out that these nanomedicines are ubiquitous across systems of medicine. In allopathy, they are used widely today for drug delivery, particularly drug delivery relating to anti-cancer drugs. It turns out in Ayurvedic bhasma, they are also present, which I didn't talk to you about, and certainly in homeopathic medicines, they are also present. So here we have a case where there is a material basis, and the material basis is a concrete evidence for the starting material to be retained in the final product. And this does not, of course, go against the grain of anything else that we've discussed today. There could be water layering around these nanoparticles. There could be radiation coming out of this. There could be a quantum chromodynamic effect with these nanoparticles. But here we have a concrete evidence that there is a material basis for the entire suite of action that homeopathic medicines have. Thank you.